Hey there, Algebra 2 students. Welcome back to Miss McGuire's classroom. I'm Miss McGuire, and for today's notes, we are going to be focusing on Unit 2, Lesson 3, Graphing Absolute Value Functions. Now, of course, I need you to put your first and last name, the period, and the date at the top right-hand corner of your paper, just like always. Today's objective is I will graph absolute value functions. Mastery will be shown by scoring at least 80% on the extra practice. So let's jump right in. Now, we've talked about absolute value equations in Unit 1. The very, first or second week of school, we learned how to solve absolute value equations that had one variable. Well, an absolute value function has two variables this time. It's going to have a variable of y and x. So an absolute value function is always going to be in the form of y equals a times the absolute value of x minus h plus k. Now this should look super similar to you because doesn't this look a whole lot like point slope form that also had h and k in it? Well, it does look a lot like point slope form, right? So absolute value functions, of course, have the absolute value symbols in them. And they also have h and k. So just like in point slope form, h and k represent an important point. HK represents the vertex of our absolute value graph. So when we graph absolute value functions, you're going to get a V-shaped graph that's either right side up or upside down. And the point at the very, very tippy top bottom or tippy top of that V-shaped graph is what we call the vertex. That point is the vertex. It's where those two V-shaped lines come to a head. All right. Then the other important thing that this equation gives us is A. And we're going to treat A like the slope. We're going to treat A like slope. And we'll get into that a whole lot more towards the end of this lesson when we graph absolute value functions by just looking at the equation. So we'll talk more about that a little later. Now, the other thing you need to know about absolute value graphs is that they have this very important line called the axis of symmetry. And the axis of symmetry cuts the absolute value graph perfectly in half. If you were to take that V shape and fold it in half on the axis of symmetry, you would notice that each side of the V is a perfect reflection of the other. So the axis of symmetry is the line that cuts the graph in perfect half. So axis of symmetry. All right, so let's make a couple notes about that. So remember the vertex of our parabola, not parabola, I'm so sorry. The vertex of our absolute value function. So the vertex of our absolute value function will always be a point HK. So we're talking about the point HK. Remember, h is the x value of the point, k is the y value of the point, just like with point slope form. So the vertex is either the highest or the lowest point on the graph. We also call that highest point the maximum, and then we call the lowest point the minimum. And we'll talk more about that later as well. Then the axis of symmetry can be shortened by just saying AOS. It is the vertical line that divides the absolute value function into two symmetrical halves. The nice thing about the axis of symmetry is that the line for the equation that we will graph for the axis of symmetry is always x equals h. Where does that h come from? That h is the same x value of your vertex. So your axis of symmetry will always match the x value of your vertex. All right, so why don't we go ahead and graph our first absolute value function. So the parent function of all absolute value functions is the equation y is equal to the absolute value of x. Let's talk about that equation for just a second and compare it to the general form. So y is equal to, well, technically, isn't there like a ghost 1 out in front of the absolute value symbols here? So it's technically 1 times the absolute value of x minus 0 plus 0. Now, how do I know that these two equations are really the same thing? That these two equations are really the same thing? Because let's simplify it. Well, what is x minus 0? Isn't that just x? And then what's the absolute value of x times 1? That's just the absolute value of x. What's the absolute value of x plus 0? Well, that's just the absolute value of x. So y equals the absolute value of x. So what I know is that in this parent function, so this is the main function of all absolute value functions, that my vertex is actually 0, 0. And I also know that my axis of symmetry then, remember, your vertex is always hk. Your axis of symmetry is always x equals h. So in our case, h is 0, so my axis of symmetry is just x equals 0. And we'll talk about how to graph that in just a minute. Well, let's use a table of values just to double check some things. I want to make sure that I graph the right thing here, right? I want to graph this function correctly. So if I plug in -3 for x, I'm going to have y is equal to the absolute value of -3. Well, the absolute value of -3 is 3. Let's do the same for -2. The absolute value of -2 is 2. Let's do the same thing for -1. The absolute value of -1 is 1. The absolute value of 0 is 0. The absolute value of 1 is 1. The absolute value of 2 is 2. The absolute value of 3 is 3. Hey, do you notice anything about these two values? What about these two values? And these two values? They're the same. I wonder if that's going to show up on the graph as a reflection. We'll see what happens. So let's graph those points. So let's graph, the first point is 0, 0, then 1, 1, then 2, 2, and 3, 3, -1, 1, -2, 2, -3, 3. And what I notice is the lowest point on this graph is right here at 0, 0. Well, didn't that match what I said my vertex was? And then I also noticed that on x equals 0, which just so happens to be the y-axis, so my axis of symmetry is x equals 0. And on every graph, I want you to label your axis of symmetry and then write the equation that is the axis of symmetry, which is x equals 0. Well, in this case, it's x equals 0. Your axis of symmetry will always be a dashed line because it's not actually part of the original function. It's just a line that we show that divides the graph in half. So what you should notice is that this point 1, 1 is 1 unit away from the axis of symmetry. So is this point. This point, 2, 2, is 2 away. Well, the point over here is also 2 away. So all of these points are perfect reflections of each other. So the axis of symmetry is dividing this graph into two symmetrical halves, which helps us as we graph later on. All right, so because this is my vertex, which is my lowest point, and I know that all the other points need to be higher than it, if it is my lowest point, then I can go ahead and graph this absolute function to increase to the far left and the far right. Because what do I get when I plug in 5? See, one thing we need to do, obviously, is label our graph. So what happens if I plug in 5? Well, what's the absolute value of 5? 5. So 5, 5 would also be on my graph right here. What would I get if I plugged in 10? I would get 10. So I know that my graph does increase off to the right forever. And same for the other side. If I plug in -6, I'm going to get -6. So again, my graph increases off to the left forever as well. So what we've just done is graphed the parent function of all absolute value functions. And we're going to get into more of what that means in Thursday and Friday's lesson. The rest of today's lesson is just focused on graphing absolute value functions in general. All right, so for example 1, I want you to identify the vertex and the axis of symmetry for each function. So for part A, y equals -2 times the absolute value of x minus 3 equals 7. What's our vertex and what's our axis of symmetry? Well, if you recall, the general form is y equals a times the absolute value of x minus h plus k. And what we want to do is to identify the vertex. Remember, the vertex is always hk. So we want to identify h and k. Well, it looks like h is 3, k is 7. So I know my vertex is 3, 7. Then remember, your axis of symmetry is just x equals h, whatever h is in the vertex. So whatever h is your axis of symmetry. Well, our h value was 3. So that means that my axis of symmetry is x equals 3. And you have to write the AOS as an equation because it is the equation of a line that you are going to graph. So you have to write it as an equation of a line. If you don't write it as an equation, you're not going to get full credit because then it's not a line that you can graph. It's just a number. So make sure you always have x equals out in front of h for your AOS. All right, now it's your turn. Look at part B. Y equals the absolute value of x plus 4 minus 2. Go ahead and identify your vertex and your axis of symmetry. All right, so your vertex should be -4, -2. Your axis of symmetry should be x equals -4. So remember, h in the general form is being subtracted. So it always has the opposite sign in the point as it does in the equation. If it's a +4 in the equation, it's a -4 in the point. Let's move on to part C. So we have y equals 1/2 times the absolute value of x minus 3 plus 4. Go ahead and tell me the vertex and the axis of symmetry for this equation. So your vertex is 3, 4. The axis of symmetry is x equals 3. Good job, guys. Let's go ahead and move on to example 2. So example 2 has you graph absolute value functions by using a table of values. So we're going to plug a bunch of x values into this function, and then we're going to have a bunch of points, and we're going to graph those points. So the first thing we obviously need to do is go ahead and label our graph. So why don't we do that real quick? All right, I just used some magic and labeled my graph real quick. So let's plug in a bunch of values. So y is equal to the negative absolute value of x. So we're going to have y is equal to the negative of the absolute value of -3. Well, the absolute value of -3 is positive 3. But then we want to take the negative of that because we have a negative sign out in front here. So we actually get negative 3. Y equals the negative of the absolute value of negative 2. We get the negative of 2, which is negative 2. Y equals the negative of the absolute value of negative 1. We get the negative of 1, negative 1. Y is equal to the negative of the absolute value of 0. Well, that's just the negative of 0, which is just 0. Y equals the negative of the absolute value of 1 is the negative of 1, so we get negative 1. Y equals the negative of the absolute value of 2. We get the negative of 2. Y is equal to the absolute value, the negative of the absolute value of 3, or the negative of 3. So we get negative 3. So let's plot those points. We get 0, 0. When we plugged in 1, we got negative 1. When we plugged in 2, we got negative 2. Negative 3 got us 3, negative 3. Negative 1 got us negative 1. Negative 2, negative 2. Negative 3, negative 3. And we start to see that our V-shaped graph, our absolute value graph, is facing downwards, which is totally allowed. That's perfectly fine. And there we go. Now we start to notice that our vertex is at 0, 0, because that is the highest point of this graph. Remember, your vertex is either the highest or the lowest point on the graph. So this is our maximum point, the highest point on the graph. It's our vertex, 0, 0. And that means that our axis of symmetry is x equals 0, because it's always x equals the h value or the x value of our vertex. And x equals 0 just so happens to be the y-axis. So we put a dashed line on x equals 0. So the axis of symmetry is x equals 0, and we put a dashed line on the y-axis. There we go. All right, why don't you go ahead and try to graph one on your own? So again, you're going to use a table of values. So graph y equals the absolute value of x minus 3 plus 2. Plug these x values in, see what kind of points you get, and then plot those points on your graph. Don't forget to label your graph. So when I plugged in all of these x values and got all of these y values, I started to realize that my graph wasn't making a V shape. But all of these values were starting to come down, and it looks like they're headed for a point of some kind. So what I did was I plugged in 4, and I added 4 to the table, and I'm going to add 5. When I add in 5, I'm going to get y is equal to the absolute value of 5 minus 3 plus 2, which is 2 plus 2, which is 4. There we go. And now I see that 2, 3 matches 4, 3, and 1, 4 matches 5, 4. And so now I'm going to start getting that V shape, that symmetrical V shape that we want. So I'm going to graph 4, 3, and 5, 4. And now I've got this V shape, and I can go ahead and draw in my lines and extend my graph to the far right and the far left, just like I wanted to. So now I can see that my vertex is 3, 2, and then my axis of symmetry is x equals 3. So if I go ahead and draw in my axis of symmetry, it's the line that divides the graph perfectly in half, and the axis of symmetry is the line x equals 3. This line right there. And there we go. We have successfully graphed this equation. All right, now I'm going to show you how to graph absolute value equations without using a table and just using the information that you get in the actual equation. So let me show you how to do that. So example 3 is all about graphing each function by identifying the vertex, axis of symmetry, and the value of a. So remember, the general form of absolute value functions is y is equal to a times the absolute value of x minus h plus k. Our vertex is the values of h and k. So in this case, our vertex will be I guess I should read the function. The equation is y equals -2/3 times x plus 1 minus 3. Or times the absolute value of x plus 1 minus 3. Our vertex, HK, is -1, -3. Our axis of symmetry is x equals h, which in this case is -1. So x equals -1. And then a is the number being multiplied by the absolute value. It's out in front of our absolute value sign. Our a in this case is -2/3. Earlier in the video, I said that we were going to treat a like slope. We're going to treat this -2/3 like slope. So let's jump into graphing this equation. So the vertex is -1, -3. So plot the point -1, -3, right there. Then when I tell you to treat a like your slope, you're going to follow slope the same way you always do. Remember, slope is rise over run. Well, since a is -2/3, that means we're going to go down 2 and over 3. So when you use a like your slope, do it to run to the right like we normally do. So remember, with -2/3, we're going to go down from this point, we're going to go down 1, 2, and to the right 1, 2, 3. So our next point would be here at 2, -5. And then do it one more time. So down 1, 2, over 1, 2, 3. You should have a point at 5, -7. And what we have is we've created the first half of our V-shaped graph. Now the other half is going to be reflected over the axis of symmetry. So remember, our axis of symmetry was x equals -1. So as a line, that's a vertical line at x equals -1. So here's -1. I'm just going to draw the line, the vertical line that goes through x equals -1. Now we're going to reflect our points across that line. I know that this line divides my graph into 2 symmetrical halves. So as you can see, this point here is 1, 2, 3 away from the axis of symmetry. So if I reflect it, it's going to be 3 away from the axis of symmetry on the other side as well. So we're going to go 1, 2, 3, and put it right here. Then we're going to do the same thing with this point. So it's 1, 2, 3, 4, 5, 6 away. So we're going to go 1, 2, 3, 4, 5, 6, and put this point over here. I'm going to erase those extra markings because I don't need them. It's not part of our graph. Okay, and then we have a couple points. So from our vertex, we're going to draw a line through those points as well. And what you should notice is the slope of the left side is up 2 over 3. Up 2 over 3, which is the opposite of down 2 over 3. So we know that our graph is correct because we've used the same slope on both sides here, or the reflected slope, I should say, on each half of our absolute value functions graph. And there we go. Oh, a couple things we need to label. You're always going to label your vertex. So our vertex is at the point -1, -3. Yep. And then our axis of symmetry is the line x equals -1. Don't forget to label that. And also, of course, label your x and y axes, draw your tick marks at every line, and then label your scale as well. All right, so now why don't you guys try to graph a problem on your own? So you're going to use the similar concept. You're going to identify your vertex, your axis of symmetry, and your A, your slope. So the first thing you do, plot your vertex. Then use your slope to find more points on the right side of your graph. The second thing you do is draw your axis of symmetry, And then the third thing, reflect your points over your axis of symmetry. We could even write those steps out real quick. So the first thing you're gonna do, plot the vertex. The second thing you're gonna do, use A as the slope on the right half of the graph. The third step, reflect, or just kidding, you want to graph the axis of symmetry. Graph the axis of symmetry. And then reflect the points on the right side over the axis of symmetry, the AOS. All right, give it a shot. So your equation is y equals 1/4 times the absolute value of x minus 4 plus 2. Identify your vertex, axis of symmetry, and A, and then use our 4 steps to get it graphed. Good luck. So I recognize that my vertex is 4, 2. My axis of symmetry is the line x equals 4, and my A is 1/4. So the first thing I'm going to do is graph the point 4, 2. Then I'm going to use A, like my slope on the right-hand side of the graph. I'm going to go up 1 over 1, 2, 3, 4. And then I'm out of room. So this is the right side of my graph. So then I'm going to graph the axis of symmetry, which is going to be a dashed line at x equals 4. I'm going to label it. And then I'm going to reflect this point across the axis of symmetry. So this point is 1, 2, 3, 4 away from it. So I'm going to go 1, 2, 3, 4 over here and plot this point. 2, 3, 4. And if I wanted to, I could create some more points over here by using this slope of up 1 and then to the left. So up 1 and then 1, 2, 3, 4. Just for fun, I'm going to extend it that way. There we go. And there we are. We've got in a graph of our absolute value function, y equals 1/4 times the absolute value of x minus 4 plus 2. Go ahead and get started on your extra practice problems in today's folder on Schoology. You're going to take a picture of those problems when you're done and submit them just like you submit your homework assignments and all that good stuff. And I'll see you back in class. Have a great day.